All right, so this is lesson 12, and today we're going to look at nonlinear models in a data context. Now, this is very similar to lesson 11, where we talked about identifying linear models. So nonlinear models just mean it's not going to be a straight line. So if we are looking at a graph, so I'll just give you a generic graph here. If we're looking at a graph, we're going to be looking at something that might be curving upwards. We could also look at some sort of graph where it might be curving and slowing down, something like this. Okay, so anywhere where we're talking about not a straight line, so something that is curved, that would be considered a nonlinear model. All right, and we're going to be looking at this in data, meaning we're going to talk about a problem where we need to use information and gather information, plot the points, and then look for a pattern that may or may not be a straight line. So the first problem is example 1, growing dahlias plants. So what's happening here is the group of students want to determine whether or not compost is beneficial in plant growth. I think we can all agree it probably is, right? So the students are going to use a dahlia flower to study the effect of composting. And in this experiment, they're going to place 8 dahlias in a bed with no compost and another 8 in a bed with compost. So they're going to measure the height of each plant over a 9-week period, and they're going to find the median growth height for each group of plants. So the table shows the results of the experiment of the dahlias grown in non-compost beds. So this first one we got to keep in mind is the non-compost bed. So they give us some sort of table, and in this table, whoops, didn't want to do that. Right. In this table, they're going to show us that in week 1, we're talking about 9 inches of growth, right? So from 0 to 1 is 9 inches. Now, that's not necessarily right away. It's more of just a initial measurement. In week 2, we're at 12.75. Week 3 is 16.25, and so on. I think you guys can get the idea there. All right, so let's move on and move to our scatter plot. So what they want us to do for exercise 1 is to graph this, okay? So I'm going to there we go, blend these together. And so for week number 1, we have to plot it at 9 inches. Now that's a little tricky here, so we're just going to go just below this 10. I think that's a good spot for it right there, okay? And week 2 is going to be at 12.75, so let's go about here. And week 3 is 16.25. Week 4 is 19.5. And again, this is somewhat arbitrary because we're really making this on a graph that is not completely graduated, meaning it doesn't show us exact numbers and exact lines of best fit. So we're doing the best we can to estimate this. All right, so there's our linear, really it's just the graph, but we're going to say it's linear. And so what we're going to do, whoops, I didn't mean to move that like that. I think we're about there. So if we look at this, we'll notice a couple of things. So the first thing is that this does move in a linear fashion. For me, if it were something that I was starting to look at, in this graph, and I probably shouldn't use a rectangle, let's use just the pen. So in this graph, if I wanted to draw some sort of line of fit, obviously we'd start the first one and we'd try to create this line right through. All right, now I'm a little bit on the low side there. But what I would do is I would try to make this right through the first and the last is where I think that it would work best. So we did that, and then we want to find the rate of change. So the rate of change for me, I would have used the first and the last. So in my first point would be at 0.1 and 9, and my second point we said, or my last point was at 10, and I got to look at my data for that. 10 would be 9 and 37.25. 9 and 37.25. So I should erase this. So again, if we're going to find the slope is the change in y over the change in x. So we're going to look at the change in y, which is 3725 minus 9 over the change in x, which is 9 minus 1. All right. So when we subtract, we end up with 28.25 over 8. If we do some quick math, we get about 3.40. All right. And this would be the rate of change of growth in time. So 3.40 is what we're saying. So it'd be 3.40 inches per week. Now, if you remember, our initial is 3.40. That's what we estimated. And now what they want us to do is they want us to subtract these. So they want us to figure out what the change was for each of these. And what you're going to find is that they're anywhere between 3.25, 3.50, and 3.75. And it's some sort of combination of these. So when we compare that, does that make sense with what we calculated? And the answer to that would be yes, it does. It does make sense because our 3.40 is kind of right in the middle of all that. So as the number of weeks increase, describe how the weekly growth is changing. We would say that the weekly growth is changing at a fairly steady rate of 3.25 to 3.75 inches per week. How does it compare to the slope? We just answered that. We would say that it is just about the same thing, right? Just about the same. Estimate the median height of the dahlia in 8.5 weeks. So if you remember when we had this graph up here, all right, so we were at 9 and, where was I? 9 and 37.25. So 9 and 37.25. And we were at 1.9. So we had this line that kind of went right between these two numbers here. And whoops, I clicked my button. So what that does is tell you what that does. That drives me crazy. Sorry about that. I'll just leave that as is. If I click the side of my pen, it just goes crazy. So we have this line right here. And so what we do is we take 8.5 weeks, we'd come up, we'd find where it fits and come across, and we'd say between 35 and 33. So anywhere between 35 and 33 inches is where it would be at 8.5 weeks. That's kind of what we're looking at there. So the next part of this is they want us to take a look at the compost bed. So the compost bed is the one where we're going to have to really focus. Okay. So what I'm going to do is I'm going to go ahead and I'm going to construct and talk about the scatter plot. So we're going to take week 1 at 10 and week 2 is 13.5. Week 3 is at 1775. Week 4 is at 21.5. 5 is at 30.5. 6 is 40.5. So we're starting to see a little bit of a curve here. 65. Okay, so we have this kind of curve motion going on right now. So this is not perfect, but we would kind of estimate this to curve upwards, kind of like that. Okay. Now I'm going to scroll down here. Is it linear? No, it's not. If we describe how it is increasing or decreasing, we're going to come back to this question. So here's the curve. Number 12 is the one that says sketch the curve through the data. When sketching a curve, do not connect the ordered pairs. If we use the curve to estimate the medium height at 8.5 weeks. So I'm going to come back to this, and that's why I wanted to leave this on here for a second. Right, so we're about there. At 8.5 weeks, this is where we have our judgment call. So 8.5 weeks is somewhere in here. And we would say that, again, it's probably about 85 inches. All right. So now if we compare that 85 inches compared to the pot without the compost is significantly different, Okay. So how does the weekly growth of the dahlias in compost beds compare to the weekly growth of the dahlias in the non-compost bed? Obviously, we should say that the compost beds are growing at an exponential rate. They're growing much faster, but not constant rate. It's just a lot faster. Now, this next graph is pretty cool. This is where they're going to estimate how fast a car was going based on the skid marks. And this is actually done by our police force. So they have us at skid marks 5 feet, speed is 10 miles per hour. So we would come in, and this is going to be hard, but this is going to be like this. And 17 is at 20. So 17 is really hard to find, but we're at 20. 65 is at 40. So 50, 65, 40, 105. Should scroll down a little bit so you guys can see this. Sorry. So 65 is at 40, 105 is at 50, 205 is at 70, and 265 is at 80. Say we're right there. So if we look at this data, we're actually kind of coming with this image here of a graph that is actually starting to slow down. That's what we're looking for. Okay, so go ahead and plot your graph at this time. I'm going to erase mine, but plot yours. If the car left a skid mark on 60 feet was an estimate for the speed of the car. So, obviously 65 is at 40. When you saw in the graph, it's probably sitting around like 35-ish. Okay. Same with 150. I'll let you estimate those based off of your graph. If you need to, go back and look at my original graph. So if a car leaves a skid mark that's twice as long as another skid mark, was it going twice as fast? I want you to explain this for yourself. I'll give you the real quick answer, though. The real quick answer is no. And I think you'll be able to prove that. If you look at the distances for 50 and the distances for 100, they're not twice as fast. All right. So, or twice as far. So we have to look at that a little bit more critically. Okay. And then that will take us to the problem set. And the problem set is what I'm going to ask you to do tonight for homework, but also for classwork today. Okay. Hopefully you've been following along. Feel free to go back and look at anything that you may or may not have missed. And we will take it from there when I see you again. Bye, guys.